Hello everyone. Welcome to Learnitor.com. Today we are going to solve the first problem in LeetCode, which is the easy one, which is the two sum. So let's get started. So in this problem, they have given an array of integer nums and integer target, return indices of the two numbers such that they add up to the target. And you may assume that means there is exactly one solution is present for this one. They have given some examples like for these examples 2, 7, 11, and 15, and having the target 9. So its answer is 0 and 1 because means 2 plus 7 is 9, and we got the answer. So we have to return the indices here. In the second problem, target is 6 and nums are 3 to 4, and over here 2 and 4 will be the answer. So they have written 1 and 2 as their indices. And in third problem, 3, 3 is there and target is 6, so their output is 0 and 1. So now let's do means check how we can solve this problem. Let's take first example and just write over here. I will write in the whiteboard. So first example 2, 7, 11, 15, and target is 9, 11, and 15. So these are the numbers. Okay, and here target is 9. Okay, so how we can solve this problem? Okay, there are two ways I can think about this. So the first one is like we can put the first index at here and then check the each of the index afterwards of this index. Let's say this is the I. Okay, then we will check 2 plus 7 whether it is 9 or not, 2 plus 11 whether it is 9 or not, 2 plus 15, like that. Okay, and similarly if means let's say for this one means 2 plus 7 is coming, so we can return uh, the output as a 0 and 1 index. Let's say we have the different target for us. Okay, let's say the new target will be 18, let's say. So how we can do that? Like first we will check like first I will be 2, and then we will check for the remaining part of the array whether it gives the exact result or not. Like 2 plus 7 is 9, 2 plus 11 is 13, 2 plus 15 is 17. So J will go on this. So this is not possible, so we can remove this thing, and then we can go for the I over here, and then we can check for the remaining part of the array. So here I is at 7, so it will check 7 plus 11 whether it is 18 or not. So 7 plus 11 is 18, so we will return output as 1 comma 2. Okay, because 7 has index 1 and 11 has index 2. Okay, so this is our answer. So similarly for let's say we have got the 26 as the target. What we will do, like first we will check for the 2, then we go for the remaining part of the array. So 2 plus 7 is 9, so this is not 26. 2 plus 11 is 13, not 26. 2 plus 15 is 17, which is not 26. So then we go for the next 7 plus 11, which is not 26. 7 plus 15, which is 22, which is not 26. Then again we go for the 11 plus 15, which is 26. So we will get the 2 and 3 as output. So this is the one of the way we can solve this problem. So let's say, so how, we will check like what will be the complexity of our problem. Okay, so what we are doing, we are picking one index and we are checking all the remaining index for its. Okay, so this j is traversing from here to here, so it is almost n. Okay, so n is the size of the array. Okay, and here I is also going from this 0th index till the n minus 1 index. So in at the end we are going from n to n minus 1, which is almost we are getting the complexity of n square. Okay, so whenever we are getting the complexity of n square, so how we can check like whether it has some optimized solution or not. Okay, so whenever we are getting n square complexity, so what will be the lesser complexity for that? So the lesser will be like n, order of n complexity, and even lesser for that is order of log n. Okay, so this is one of the way. So we will check like how we can do with order of n. Okay, so I will erase other things which we not required. So whenever we are getting the n square complexity, we will just check whether we will get the optimized solution or not. So how we can approach for the optimized solution, we will check like if we get the n square complexity, how we can do for the n. If we have the complexity of n, then how we can do for the complexity of log n. Okay, so one of the way is like you can say like we can sort the array. So sorting things they have not explained over here, like whether our inputted thing is sorted or not, or even in the example they have even some unsorted array. But yeah, I mean the sorting is one of the way, but we have to return their indices. So we're not able to return the indices in that case, because in the sorting things, let's say if we sort this example like 2 3 4, then we check like for the two sum like 2 and the last element. Okay, 2n plus 4 is 6. Okay, and means if we got the target, then that's okay. So if we got the sum which is greater than the target, then we can go from the lesser from the end of the side. So means I will explain in through this way. Like if so this is the sorted one. So in the sorted case, how we can do like, so 2 first we go like 2 plus 15, which is 17. Okay, and our target is 9. So 17 sum is greater than 9. So we need to decrement this thing, this index. So the new index will be at here. So 2 plus 11 is 13. Okay, so still it is greater than the our targets. So we need to shift this index from here to here. Then we got the 2 plus 7 as a 9. But in this case, they have, so if we want to return only elements like 2 7 as the output, then this will work. But in our case, they have share, means they need output in the indices of that. So and our input they have given is not in sorted order. So we can use the other method which I am going to discuss with you. Okay, so what will be that method? So we can going to use the unordered map. So you may be known like unordered map is using the hashing functionality, and it has the key and the value part. So in the key part, we will put that element and then their index, which is 0. So we got the first element 2 and its index is 0. And uh, whenever we got means we are in the first index, then I will go from the start like, so we have the 2 as the index. 2 means we are in the 0th index. Okay. So in the first index, whenever we are there, so our unordered map is initially empty. Okay, let's say this is the map and it is initially empty. So it will, what it will check, so it will check for the target minus 2 whether it is present in the this unordered map or not. And for searching in the unordered map, it takes the order of 1 complexity. So this needs to be remembered for you. Okay, so whenever 2 is there, so map does not contains any elements. So we just, so if we not found anything, then we just put that element into the unordered map with value as its indices. Okay, then we go for the next index over here, which is 7. So whenever 7 is coming, we do like 9 minus 7, which is 2. We check whether 2 is already present in this unordered map or not. So 2 is already present. So what we can return, like, so 2's index, which is 0, and 7's index, which is 1. Let's say we have the uh, target as a 26. For means better understanding of you, I'm taking the target as a 26. Okay, let's say, yeah, so at the start, so our map is empty. So what we can do, like our index is at 2. So we will check like 26 minus 2, whether 24 is present in the map or not. So it is not present, just we will insert it into the map. And then we go to the next element, which is 7. So now we check for the 26 minus 7, which is 19, whether 19 is present in the map or not. So it is not present. So we just insert that element into the map with their indices, and our now index will be at 11th position. So 26 minus 11, which is 15, we check whether here 15 is present or not. So 15 is not present, so we just put 11 and its indices as a 2 over here. Then we go for the next 15. We do like 26 minus 15, whether present in the map. So 26 minus 15 is 11, and 11 is present in the map, so which has the indices 2. So what we will do, return as 2 3 as our output. So let's code our problem. So I'm going to code the both approach. The first, what we have seen, like order of n square problem, and the second, in this problem, it is taking like, means we are, our loop is going in one way, like we first check 2, then 7, then 11, and then 15. So this will take the order of n size. And this unordered map is also we have taken, so which takes also order of n size. Okay, so this is the time complexity and this is the space complexity, and whatever the solution earlier we have shared, so which has the complexity of order of n square. So compared to this time complexity, this is the most complex optimized solution for one. Okay, let's do the coding. So in the coding also you can going to find out like the complexity. So I will also share that thing also in the time of the coding. So we need to take the two integers, like integer I is equal to 0 and j should be at 1. Okay, so that is what we are doing. So we go from the I is equal to 0 till I has the nums dot size I plus plus, and we have to take integer j is equal to, which needs to be starts from the ith plus 1. Okay, so whenever we are in the first solution, whenever we are there in that here 0th location, we are traversing this array from the first index. So we are going to start from the j is equal to I plus 1, and j should be less than nums dot size and j plus plus. Okay, so here you can say like I is still the nums dot size. We can do like um, nums dot size minus 1 in the case, because whenever we are at 11th position, after that we are not going for the 15 for the ith case, because j is I plus 1 starting from here. So this way this code will work anyway. Okay, because j is I plus 1, and this will not go inside this, so it will go outside of the loop in that case. So we will check like if nums of I plus nums of j exactly having the target value, we will just return I comma j as the output. Okay, so this is the one of the way to solve this problem, like nums of I plus nums of j exactly equal to target. If we got that, then we will just return. So here you can see like we have taken two for loops. So whenever we are taking the nested for loop, so it is going to till the nums of size. Okay, and this is also going till nums of size. So this is n and this is n, so it's almost taking the order of n square. Okay, so just run the problem, and we will check like all the test cases got passed, and we will submit this thing, and we will check like time complexity as it has a more time complexity over here. So it is taken 49 milliseconds, and it beats 38.50% of users with C++. So we are at here, and we have to go for the here. So let's do for our second solution. Anyway, I have forgot, but yeah, so this thing is not required. So you can remove this thing, and this for loop is means this much code is not required for us. Okay, so let's do the other approach, which is unordered map, which has key as integer and value as integer. And let's go for the each of the values in the nums. So this is the one of the modern way of writing the for loop in the C++. So this auto is automatic keyword which takes the nums each values. So here value will be integer, so it is automatically taking. So auto keyword is newly introduced in C++, and it will check for the each of the element in C++. So if we check like if in our unordered map already contains our value, sorry, target minus value. So whether here we are checking like whether we have got the target minus value is already present in the count or not. Okay, yeah, we have to return the integer, so I need to write the normal for loop. So we go for the normal for loop because we have to add the its indices. So for that I have used, means you can use in the both way, like for the each element you can take like that element whatever I earlier showed you, and this is also one of the way which is the regular way. So whenever we are getting this, then we just return m of target minus value comma I, so which is our answer. And if it is not present, then we will just insert our element into the map, which is, so here it is not value, it is nums of I, because we have changed our for loop. Okay, and we have to insert nums of I and its indices. Okay, so whenever we will get, so it will return. Okay, we will. So this is the unordered map we have used, and we are here in count. Count is the function which searches whether particular element is present, particular key is present in the that unordered map or not. So it will return true or false in that case. So if it is present, then it will return true. So it will go inside this, and so we can return that thing. And if it is not, then we just adding it into our unordered map. So let's run this code. I hope it work. Oh, yeah. So I need to use this circular bracket. So I have made a silly mistake over here. Yeah, so this will work. And let's submit our code. Yeah, so it almost beats 55.51%, and it comes inside this one. So let's check the what will be the uh, most optimized solution. So they have also did the same thing. and is pushing into the only vector I just written directly, and is inserting that element. So our approach and his approach is also same. So this is the one of the way to effectively use the lead code. Means we can check the most efficient code over here, and we can find out like how our code or my code is different than they. So thank you guys. So this is the first video. I hope you can understand these things, and yeah, happy coding. Thank you very much.